Howdy folks, Mr. Reed here, and welcome to One More Question. So what I'm going to be taking a look at right now is the idea or concept of taking a physical situation where some object is moving in a circle, and I want to keep track of one of the dimensions of motion, so whether that be vertical or horizontal. In this case, it's actually going to be vertical. But in order to model this motion, I'm going to use either a sine or a cosine function, but it's not going to be given to me. I have to set it up myself using the information in the problem. Once we have that equation set up, we'll be able to use that equation in order to solve for some unknowns that we're asked to solve for at the beginning of this problem. So if you want to see the setup of an equation to model a physical situation of something moving in a circle, and then do a little solving, you're in the right place. So let's get to it. All right, I'm going to insult you a little bit, and I'm going to read to you. Apparently I like the sound of my own voice, but here goes. Henry Hamster likes to spin his hamster wheel really fast and then grab on for dear life to see outside the window in his room. His wheel has a diameter of 8 inches, and the bottom of the wheel is located 2 inches off the bottom of his cage. When Henry is at or above 9 inches from the bottom of his cage, he can see out the window. If one rotation takes 0.65 seconds, how much time does Henry get to look out the window in that first rotation? So, what I'm going to end up doing here is probably trying to distill that wall of text into something a little more manageable for us. So first off, I can understand in this case that we have poor little Henry is going around really fast, and then what he does is he grips onto his hamster wheel. That kind of locks him into the position on the wheel, so he's not just kind of keeping pace with it along the bottom anymore. He grabs on and goes for a ride. Now, don't think about it too great or too carefully, because if you do, you might realize that he'd have to be upside down and backwards basically, unless he did a really weird grip on the bottom. So we're not going to get too into the details of Mr. Reed's weird question. What we want to do though is realize that as he does this, he's going to be moving in a circle. Specifically, we're told that when he's above a certain height off the bottom of the cage, he's able to see out of a window. Now, again, as I said, don't worry too much about the orientation of the poor hamster as he's going through this, because he wouldn't... Anyway, maybe the window is off to the side of the wheel. Luckily, I didn't really discuss that too much. But let's say he's tilting his head off to the side, and we'll go from there. Okay, so we're going to set up a sine or a cosine function here. Now, it doesn't actually say whether this hamster is starting at the bottom at time is equal to 0 or not. I'm going to assume that he is, but it doesn't really matter, because whether it's a sine or a cosine function, the amount of time that he spends up at the top is actually going to be identical in either of those cases. So for this time, it doesn't really matter. If you were trying to find a time relative to the start, that would matter a lot, but in this case, we're trying to find a time period between a couple of points. Specifically, the point when we reach 9 inches from the bottom of the cage, and the point which we then descend below 9 inches from the bottom of the cage a little bit later. So I am going to actually set up a negative cosine function. I know that might seem a little weird, but the reason behind that is because I'm viewing it as the hamster being at the bottom at time is equal to 0. And for me, just from a mental point of view, if I'm set on that, well, I want my equation to go along with that too. So I'm going to basically set what's going on here to mean that the bottom of my cage is going to be my height is equal to 0. Now, the bottom of my cage is not where the hamster wheel is located. Actually, the hamster wheel is 2 inches off of the bottom, and so I have this thing that's kind of kicking around, so the bottom of the wheel is at that 2 inches, and then the wheel itself is 8 inches in diameter, so from this point to this point is 8 inches. What I'm interested in finding out is when Henry is spending his time at 9 inches above the top of his, or the bottom of his cage. So that's going to be on this section of the circle. So if I can find out how much time in this first rotation Henry is spending above this particular cutoff, then that's what I'm being asked to find out in this particular problem. So out of these things that are given, what's important for the next part, if I'm kind of moving left to right through setting up my equation, is the amplitude. So the amplitude, I discussed in a previous video that would be related to the radius if we're talking about moving around in a circle, because we want our function that's modeling what's going on here. If you'll kind of forgive me for doing a crummy negative cosine function off to the side, then what we want is for this thing to basically be at the same relative height at every single point along this, which means that my amplitude has to go from the middle to the top or the middle to the bottom. That has to be equal to the radius of the circle. So in this case, we are going to say that radius ends up having to be a 4, or half of the diameter. Okay, so I do not and I will not ever actually flip this thing left to right or right to left. I'm going to set it up as a vertical flip. So in this case, it's a negative cosine function. I'm not going to then flip it this way too. I'll never end up doing that, so no need to even explore it. But we do want the period to match the period given in the question. So we are going to take this b value and say that it's actually 2 pi times 1 over the b value, which is the stretch, is supposed to be equal to 0.65 seconds. Now we could use 13/20ths, I guess, for 0.65. Trying to think if that might actually be nicer to do in the long run. I think I'm going to do it just because I like fractions, but don't read too much into this. It's not super important. All right, so what I'm going to do is going to solve for that b value and say that it is 40 pi over 13. Okay, so you could also have that represented as a decimal, and that would be fine too. But I'm going to use 40 pi over 13 in that particular position. Now, I am going to say that my x value is actually a t value. So I'm going to change that little thing inside of my function to a t, because I'd like this to have it depend on time, specifically time measured in seconds. But we have picked this time so that... So I probably should bracket it in the same color, so that it does not need to be shifted at all, because I'm saying it starts at the bottom, which is a negative cosine function, so no phase shift required, and we're done that particular part. Now, I am going to say that the table is my h is equal to 0. I've already labeled that in my picture. So what that ends up meaning is that my center of my wheel, or the center of my function, has to be at the correct position above the table, which is 2 inches to the bottom of the wheel, and then another radius, or 4 inches, to the center, which would put me at +6. So I now have an equation, and we are going to get rid of all that junk up above, because we're going to need to use that equation in a moment. So if you're ready to get rid of that, then let's do it. 1, 2, 3. All right. So what we're going to do is use all that stuff that's written there to solve for when this particular thing is at the right height. So I want to know, what times is this thing actually at a height of 9 inches off the table? We're going to find that our calculated value from a calculator is going to give us one of these particular answers. So I'm going to say f of t is equal to 9, which is equal to negative 4 cosine of 40 pi over 13t plus 6. And so I'm going to subtract 6 from both sides, which will give me 3, divide by negative 4, and say that's equal to cosine of 40 pi over 13t. And then what I'm going to do from there is I'm actually going to perform the inverse cosine calculation. Now, I'm going to have to use the another little snap, because I forgot my calculator. And that's kind of awkward. So we're going to get that calculator back in just a moment. 1, 2, 3. Don't you love it when things just appear out of midair? All right. So what I'm going to do with this particular thing is I'm going to take the inverse cosine of 3 over negative 4, and my calculator is measuring it in radians right now, which corresponds to something that I kind of want to be unitless. I haven't had a degree conversion in here, so I feel much better about it this way. So we would have on my calculator that it's 2.419, I'm going to round it to radians. If we take, and I'm going to draw it up in kind of a little bit of a kind of weird spot, but if we look at where this is, I actually have it in this quadrant right here. So 1.57 would be up to this spot, and then if we go a little bit further, we might get to 2.42ish, but not quite to 3.14, which would be pi, or the flat angle there. Now, I'm also going to have another place where cosine is negative. That's going to be to the left of the axis, so it's going to be something like this angle right here. Now, that angle is actually, it's 2 pi minus this same angle that I just came from. So I'm going to say on my calculator here, I'm going to take pi times 2 and then subtract 2.419. So that's going to give me 3.864. Now, that's actually equal to 40 pi over 13t, and then the other one's equal to 40 pi over 13t. If I was wanting to solve this generally for all times where this happened, I would also do my little plus 2 pi k, where k is an element of the set of integers. I do not have to do that right here though, and the reason why is because these are the first 2 times where this particular setup is going to happen. And if you can envision poor little Henry here, he's grabbing on for dear life and he's going whoop, so he gets up to 9 inches, and then you start your timer. And that happens for the first time when 40 pi over 13t is equal to 2.419. So we're going to solve for what t value that is, and then he continues going around the top of our circle, and then we hit our timer again because he's going to get to the place where 40 pi over 13t is equal to 3.864. So let's actually solve for those t values, and then we'll be able to subtract the 2 times to find the time interval. So we have 2.419 times 13 divided by 40 pi. And so I get a t value of 0.25. I'm going to just round it to, I'm going to say 250 seconds. And then my other time is going to end up being 3.864 times 13 divided by 40 pi. And so we would end up there with 0.3. Ooh, that rounds to 40. Yeah, that's actually pretty nice, but 400 seconds. Now, so what that means is that our time period, or I'm going to call it delta t, is equal to 0.5150 seconds. So that is how long little Henry Hamster is going to be able to see out his window if we follow along with the wording of the original question. So that is what I would do in order to model something that is going through circular motion. I would come up with a sine or a cosine equation that I feel comfortable with by looking at the radius of the circle that it's moving in, the period that I'm trying to model, whether this thing needs to be, if I can just discuss it using either a positive or negative cosine or sine, or whether it needs a phase shift in there too. This one didn't. And whether I want my answer to kick out or be able to discuss things in terms of some specific height that I want to track that is not the center of the circle. If that's the case, then I want to have a phase shift that is puts in the right spot. So that's everything for now. That is an example of what we were trying to do, modeling things using a sinusoidal function. So if you found that one helpful, like, subscribe, and as always, take care, folks.